located about 3,900 kilometers south of the town of Christchurch within Antarctica. This towering stratovolcano is located only 37 kilometers north of McMurdo Station, both of which are on Ross Island. Ross Island is itself an interesting feature, with its unusual 78-kilometer wide edifice being formed by 4 central volcanoes and 1 volcanic field, with these representing the approximate outlines of each feature. Only Mount Erebus is still active while the other 4 volcanic complexes are extinct. These volcanoes owe their existence far away from geologic setting any tectonic plate boundary to 2 factors. The first factor is a feature that defines much of the region's modern volcanoes, a failed system known as the West Antarctic Rift System. Due to thinning crust associated with the breakup of the supercontinent Gondwana 180 million years ago, portions of East and West Antarctica spread apart in a manner similar to the modern basin and range in the United States. While rifting largely ceased many millions of years ago, it left behind numerous large rift valleys and faults that would serve as paths of least resistance for future magma to potentially intrude into. One of these rifts, known as the Terror Rift, was one such location, so when a mantle plume known as the Erebus hotspot interacted with it, large volumes of alkali element-rich molten rock were sent upwards, forming a chain of alkali-rich volcanoes. Geologic history: Mount Erebus in particular began forming 1.3 million years ago, when alkali basanite lava erupted onto the surface 22 kilometers west-southwest of its modern summit. Erupting from fissures, and then from cinder cones, a series of fluid lava flows spread across the ice-covered landscape to form a fairly flat lava plateau. Across the next 100,000 years, numerous other similar small-scale eruptions occurred, creating the modern volcanics seen near Cape Barne. Eruptive activity eventually shifted to its present location around 1.1 million years ago, and through numerous mildly explosive eruptions that emplaced fluid lava, began constructing a large shield volcano. Continued eruptions built a vast edifice, with occasional flank cinder cones adding lava further away from its summit. However, over time the magma in Erebus's magma chamber became more silica-rich, causing eruptions to become more explosive and for erupted lavas to become more viscous. Thus, eventually a stratovolcano building phase of the volcano began, causing its profile to become notably steeper near its summit. By 80,000 years ago, Erebus through overlapping layers of lava and ash had likely grown to 3,500 in height. However, a major ultraplinian eruption would eventually follow, probably around 39,000 two major eruptions years ago, causing the top of the main cone to collapse into a multi-kilometer-wide caldera. The northeast rim of this caldera can still be seen today, which is known as Fang Ridge. After another episode of cone building, a second caldera-forming eruption occurred 18,000 years ago of a similar intensity that formed a 4.5-kilometer-wide caldera. Multiple voluminous phonolite lava flows followed, especially between 7,000 and 4,000 years ago, reconstructing the central cone and creating Erebus's modern appearance. Recent eruptive activity from Erebus's summit has been largely defined by large strombolian explosions that eject bombs of lava beyond its crater rim about once every 30 to 180 minutes. Was 3,500 meters tall. These eruptions are too small and too remote to directly affect anyone at McMurdo, with there only being a risk to people further away if a future Plinian or ultraplinian eruption to occur, with the theoretical potential for ash to travel multiple hundreds of kilometers away. Thankfully, the risk of this is quite low. As a final note, I would like to thank my new patron Juzela Maui for supporting this channel.